Okay, so the first thing we want to do is go into Fluent. We're going to go start off with a new designer model geometry. When that comes up, I'll share that screen. So I'm hitting new share. Let me plug it onto our designer model geometry. We hit our XY plane. We bounce it out. What we're going to do is going to sketch that cylinder. So we sketch this, make this whatever size, dimensionize it. To click diameter, change that, and we change this to 1 to make it simple for ourselves. And then you can get rid of this dimension afterwards. But here's our new cylinder. And what we're going to do is make a control surface now, basically with the box that we are going to be analyzing this cylinder in. And so what I'm doing is just making the dimensions of the 50 by 50 box, because it's going to be much bigger than 1 meter. Actually, it should be. This needs to be deleted. Sketching. Get rid of this line. Sketching this one, this line right here, be deleted. Need to redo it. Line though, here, here. Now we're gonna do the dimensions of all of them. So general, 1, 2, 3, 4. I'm going to change these dimensions to all the 25 to get the outline of my box. Once that's done, we have the outline of my box. So we're going to go ahead and draw a rectangular box, or for us a square, from here to here. And now we can get rid of all these excess lines that we created because they don't actually matter and they get in the way. So now we're left with these lines and our edge. So now what we're going to do is go to modeling. We're going to go into concepts, surface from sketches, and then we're going to click XY plane, sketchy sketches. We have all our sketches included. Hit apply, and then generate. Now we have our control surface, and we're done with this part of the section. So what we're going to do now is go into our work bench. We're going to go ahead and start up a mesh. So if we green check, that means we're good to go for the mesh. Now that we have our mesh, let me share the screen for that. Our meshing. We have our control surface here. Click on here. We'll start our mesh. What we're going to do is insert a method into here. And our method is we're going to select this, and we're going to put this as triangles. And then we're going to hit generate. This is going to give us basically a nice triangular mesh. We can then look into statistics and see how many nodes and elements we have into here. So after this, what we're going to do is actually we're going to change the element size to 1 meter and generate. So now you can see we have a lot more. I'll show about 3,000 for that. So now we're going to insert for here, insert some sizing. And then we are going to click on this. We're going to get the edge to get into this. We'll hit apply. And the element size, what we do here is going to be 0.05 or 0.005. and then this should be hard. And then we can hit generate. So now that we have our new thing, we can look it back into mesh, look at the statistics. We have a lot more this time. So now what we're going to do is go into here, and we're going to insert a inflation onto this. So we'll take this as our geometry. In our boundary, we're going to click this. We're going to change this to first layer thickness. And our first layer height is going to be, let's do 0.02. Our maximum layers, we'll do 100. And the growth rate we'll put as 2.5. And then we can hit generate and see what we get. So now that we have we've finished that, you can see that it's pretty, there's lots and lots of nodes and elements near that area over there around the cylinder. So what we still don't have enough. So what I recommend doing is changing this to, let's say, 0.02 and hitting generate to get that final amount. So I made a mistake. This should be actually 0.2. If not, that would be way too much. So now we will try to generate that instead. So now our mesh is finished meshing, and we have enough, basically enough nodes and elements. So now what we're going to do is click on this. We can define our boundary controls. Yeah. Geometry. Click this edge. Yeah. Create name selection, or name this one, or velocity inlet. Hit OK. For this one, we will name our pressure outlet. Hit OK. Just make sure I'm still sharing. And then for these ones, we're going to name these symmetry. And then our final one is going to be our cylinder wall. So now that we have all of our name selections, we're good to go into Fluent. First thing you want to do is update this. We have our little check mark. Now we're good to go into Fluent. So we'll go into Fluent now. Make sure you hit double precision when you're launching Fluent. Let me share the screen for Fluent. It's ready. Yeah. So now, now that we're in Fluent, what we're going to do for our case is going to make this one a laminar mod. So we're going to want to have energy on. Our viscosity, we're going to want to make this viscosity, we're going to make this laminar. And the one biggest thing we need to do is make sure that our materials that we're gonna have the right Reynolds number. So we're gonna do that by changing the density. We're changing this to 1. We're gonna change the viscosity to, I believe, for 1500, no, 150,000, no, 150, yeah, 150,000 Reynolds number. You change it to this. Hit change and close, and then we can also just go into our battery conditions, check into our inlet. We're going to make this velocity inlet 10 meters. So we'll make this 10 meters. Hit apply and close. We're not going to do anything into our internal or outlet or symmetry, but our cylinder wall, we will change this. And since we're rotating it, we're gonna have this one rotating at negative 20 radians per second on the wall. So moving wall, rotational, I'm gonna put this as negative 20. And then we should be good. So we hit apply and close. So now we have that done. We have our battery conditions done. We're gonna click our reference values to make sure everything's good. We're gonna compute from cylinder wall. Actually, it doesn't really matter. Velocity inlet. Everything looks good. Let me just check cell conditions, our fluid conditions, and our fluid conditions will let us know if our viscosity is, or our fluid is 6.67 times 10 to the negative 9. So edit, yep, we're all good, so nothing worries there. So we're good for that. So basically, I've set up everything. You can also check the, no, I mean, that's everything for basically what we need for flow. So now we're gonna go into methods, and we're gonna make this simple, pressure as presto, and we'll be good from there. And then our big thing is you want to make sure they're actually close. We want to see if our residuals are good. So our residuals are acceptable range. So hit OK. And now what we want to do is initialize this process. So we're going to do hybrid initialization, initialize it. And actually, I just realized I should probably set it to 35. So let's go to more settings. Let's go to put this at 35. Hit OK, and then we'll initialize this again. Yes. And this will give us 35 emissions. You can see the values going lower, so that's a good sign. And then what we'll do is run our calculation. And run our calculation, what we're going to do is we're going to put this to 1,000 iterations. And we're going to calculate. And you're ready to go. And this is going to take a while. I'll come back to when it's done. So for sake of time, I'm just going to stop it now. And so now it's going to have everything come in, calculation complete. Now we're going to look into our contours. So for pressure, we're going to click all these, get rid of this. This will be for static pressure. So compute, then hit, actually, yes, save and display. This is what it will look like. And then for velocity, we hit compute, save and display. And that's usually what you're gonna look like. Now, since I didn't write all the iterations, it's not gonna be exact and what it should look like because it didn't converge. But if it did converge, it'd be a little bit more smoother and have all the velocity on it. So I close with that. And next thing we're gonna go to is plotting our XY plots. So what we're gonna do for this one is we're gonna put this to a pressure coefficient. We're gonna do cylinder wall, direction, everything else is good. Save and plot. And this, as you can see, is the pressure coefficient kind of going up and down as it goes around. Basically, I believe this would be the diameter of the cylinder. And then what we're also going to do is going to velocity, same thing, save and plot. And since this is a no slip condition, it's going to be a 0 velocity. And then what else we're going to do is go into our forces. Our forces, we're going to hit cylinder wall, which is going to give us the drag coefficient and force. So we hit print. It'll come out right here. As you can see, our pressure coefficient is going to be this number. And then we do the same thing for lift, though. For lift, we're going to change it to 0, and then change the y to 1. We hit print, and then we will get a new pressure coefficient, which would be this. And then typically what we would do from here is that now we're done with Fluent. We could leave Fluent, new share, go into workbench, hit share, and we would all be good to go. We would hit update, I believe. Everything would be good. And then we would try to go into results. Unfortunately, results does not work onto my laptop. If you go into results, then you think it's the streamline, so click the streamline button, and you'll be good to go after that. But since results does not work on my laptop, unfortunately, I cannot display it on here. Happens is it pulls up this PST thing, which leads to nowhere, regardless of it being ready or not. If I click onto here, just for the sake of, I could wait longer while this thing is still loading, but just for the sake, I go into here, it says that I don't have, I can't perceive of libq monitor data. So since I can't do any of that, I can't show you the slipstream, the streamlines. But yeah, that's all.